Alright, this video is going to be about division of whole numbers. We're going to be building off of what we addressed in the first video on multiplication, so if you haven't watched that, I would recommend going back and looking at it. Earlier we defined multiplication as the sum of A segments, each of length B. So if we had, let's say we have 4 segments that are each a length of 3 inches, then the total length of what we have, the total length of wood, let's say, that we have, is going to be 3 plus 3 plus 3 plus 3, or 12. Well, division has an inverse relationship to multiplication. If A times B is C, then C divided by B is going to be A. And let's take a look at that. If we have, in this example, 5 pieces of wood that are each 2 inches long, then the total amount of wood we have is going to be 10 inches. 2 plus 2 plus 2 plus 2 plus 2, or 10. So that's A times B equals C. Well, the inverse of that, if we have something that's 10 inches long and we want to divide it into 2-inch pieces, we're going to get 5 pieces. C divided by B is going to equal A. We also talked about things in the context of multiples. 3 times 5 equals 15. That means 15 is the third multiple of 5. If we count up by 5s, we're going to go 5, 10, 15. All right, so we count up by 5s. The third number is going to be 15. And therefore, 15 divided by 5, we're saying, well, 15, what multiple of 5 is 15? Well, it's the third multiple, 5, 10, 15. We can look at this on a number line. 3 times 2, what's the third multiple of 2? Well, the first multiple is 2. The next multiple is 4. So the third multiple of 2 is 6. 3 times 2 equals 6. So when we say 6 divided by 2, we're saying, what multiple of 2 is 6? Well, it's not the first. The first multiple of 2 is 2. And it's not the second multiple, that's 4. It is the third multiple, which equals 6. And we can do some problems. 15 divided by 3. We say, okay, well, let's see. If we have something 15 inches long, we divide it into lengths of 3. Well, we got 1, that's the first multiple. The next multiple. The next multiple, that's the third multiple, right? The fourth multiple. The fifth. 15 divided by 3 is 5. 18 divided by 6. Our first multiple is 6, our next one is 12, and then 18. This is the third multiple. Now illustrate, 4 times 3 means 4 segments each of length 3. So then 12 divided by 3, how many segments are there if we divide 12 into segments each of length 3? Well, okay, that's going to be 4. We're going to get 4 segments. By definition, when asked what 4 times 3 is, we're saying, what's the total length if we've got 4 segments that are each a length of 3? 3, 6, 9, 12. 12 would be the answer. Given the commutative property, we know that we can look at this really either way. 4 segments that each have a length of 3. 3, 6, 9, 12. Or 3 segments that each have a length of 4. 4, 8, 12. When we think about division, when we're asked to find the quotient, which is the answer of a division problem, 12 divided by 4, we must look at our definition of division. The quotient could be the length of segment A when divided into B equal parts. If we have here 12, let's say, right? And we say, okay, well, 12 divided into 4 equal parts, each one is going to have a length of 3. That's 3, that's 3, that's 3. Each one of these is a length of 3. Or we could also say, if we have 12, and we divide it into segments that each have a length of 4, how many segments will there be? Well, there's 1, 2, there's 3 segments, because 12 is the third multiple of 4. 4, 8, 12. Both interpretations are correct because of the commutative nature of multiplication. If I'm building a porch for my backyard, and I've got one long piece of wood that's 18 feet long, and I'm going to divide it into 6-foot-long segments, how many posts can I make? Well, in this example, we're taking 18, and we're saying I need each segment to be 6 feet. Well, okay, I cut my first cut, 6 feet, and I got 6 feet. Well, now I'm going to cut another 6-foot one. Well, now my 2 posts together, I've gotten 12 feet. And then I make another 6-foot cut, I'm out of wood. I managed to get exactly 3 6-foot posts from my 18-foot long piece of wood. Now, switching those numbers, thinking of the commutative property of multiplication, I say, okay, I've got a loaf of bread that is exactly 18 inches wide, and I have 6 dinner guests that I want each to have a slice of bread. If I use all the bread, how wide will each slice be? I'm saying, okay, well, I know that I have to divide 18 into 6 equal parts. So I'm saying, okay, well, how many parts will I get? Well, let's see. If I count it by 3, well, okay, 1, 2, 3, 4, 5, 6. I can get 6 slices that each have a width of 3 inches. Both cases, I have wound up with the same answer. It's just a matter of whether or not I'm thinking of it in the context of how long each segment is or how many segments there are. And that's what I'm stating here. There are 3 groups of 6, 3 times 6. Or there are 6 groups, each of length 3, which would be 6 times 3. Both get you back to 18. Now we run into a unique problem here. 16 divided by 5. I say, okay, well, first multiple of 5 is 5, so that's not the answer. 10, that's not the answer. 15, say, okay, well, I need to divide 16 by 5. Well, I can get 3 segments, each of length 5, but I can't really get 4, can I? Because my total length that I'm dividing is 16. So the answer is 3. My quotient is 3. But it's important to notate that I actually still have this 1 extra inch. We're going to call this a remainder of 1, which is what I just illustrated here. We can also think of this kind of a little bit more geometrically and say, okay, I've got these boxes, and I sell marbles, let's say, with a fascinating job. And my box can hold 5 marbles. So I've got 1, 2, 3, 4, 5. I say, okay, I filled my first box. I can ship 1 box with these 16 marbles. And I've got 1, 2, 3, 4, 5. Okay, I filled my second box. Is that going to go under again? Yeah, so, all right, I filled my third box. But I can't fill a 4th box, can I? I'm not going to ship off that 4th box because it's not full. So I have filled 3 boxes. 3 is the number of boxes I can fill. But I still have a marble left over. So my answer is 3 with a remainder of 1. In general, the remainder of a value is going to come out to be A minus QB. I say, okay, well, A is the number that I'm dividing. So in the previous example, this was 15 divided by 5. So 15, my quotient is 3. And so I say, okay, well, 3 times 5. So I've got 16 as my original number, minus 3 times 5, that's 15. And my remainder is then R, or what's left over. 17 divided by 5, well, the quotient is going to be 3. 5 times 3 is 15. And then 17 minus 15, my remainder is 2. Here, same example. I say, okay, well, what can I do here? I've got, let's see, first 3, 6, 9, 12. My quotient is 4. And 4 times 3 is 12. Well, 13 minus 12, that means there's a remainder of 1. I'll let you do that problem. In general, if you take the quotient and the length that we're dividing into, and we add the remainder, that should get back to the original length that's being divided. So here's a few extra problems for you to do without the number line. And this is just the basic principle of division. And we're not going to go much past this right now because we're going to dive into this a lot more when we start talking about fractions.